Great. So welcome everyone. For anyone I haven't met, I'm Ellen. I'm from the Northern Real Farming Conference team, and I'm just helping out with this session. I'd like to welcome you to this session about safeguarding our food and the issues around GM. And I'd like to introduce our three speakers, Liz, Steve and Charlotte. And I'm really just going to hand over to them to get going. They're going to talk for about 40 minutes and then there'll be opportunity for discussion and chat. So do feel free to add your questions to the chat as we go through and we'll make sure we come back to those. Great, over to you then, Liz. Thank you so much.
Okay, right. Hi everybody. I'm going to do sharing a screen with a PowerPoint, so you don't have to just look at me the whole time. As ever, this is the hardest bit of the whole thing, isn't it? Let's see if we can get that running properly. There we go. Does that all look right to everybody? Excellent, excellent. Okay, well, hi, and yes, welcome everybody. I'm really pleased to be doing this session. My name's Liz O'Neill. I'm the director of GM Freeze, which is the UK umbrella campaign challenging the use of genetic engineering in food and farming. I'm going to kick us off with a focus on what new GMOs are and why they generally present a risk to agroecology. Then Steve is going to talk about alternatives and the importance of regulation, and then I'm going to come back to talk about the current political situation, and then we will leave lots of time for questions, and Charlotte is going to actually chair the questions for us. So if she probes you about your questions, that's why she's doing that. I also need to, just before we sort of get really into the content, give Pete Ritchie's apologies. So Pete is the Executive Director of Nourish Scotland, and he was going to join us to discuss the particular issues north of the border. He's taken some time off. I mean, quite frankly, he seemed to be at everything at COP26, so I'm amazed he's still standing. So he's not able to join us, but I will do my best to cover the Scottish situation in the second bit of presentation that I'm going to do. Okay, so the first thing to say on talking about what new GMOs are is that the terminology is very, very loaded. I've used that term new GMOs, and that is largely because what you've probably heard them called is gene editing or genome editing, but gene editing is GM with better PR. It absolutely is genetic modification, and it's really, really important to be aware of that through all of what we are going to discuss. The reason that I say that is the term genetically modified is legally defined jargon, and it's jargon for manipulating the DNA of a living organism in the lab. That definition covers a whole variety of techniques that may or may not involve adding DNA from another species. And that definition is held in law. It's regulated in the UK under what's called retained EU law. So I'll talk more about that later, but that's EU law that we brought in as part of the Brexit process. So it is defined in law. So kind of having set that scene, I'm going to go on now to explain a bit about why these new GMOs are just as irresponsible, just as unfair, and just as unsustainable as their older counterparts. So I'll take those in turn. So, why do I say that new GMOs are irresponsible? Well, older GM techniques were completely random about where the DNA changes were made. These newer techniques are a bit more targeted, in that they actually have a specific place in the genome in mind where they're supposed to be making the changes. But targeting is not the same thing as actually achieving your target. Targeting isn't the same thing as precision, and actually even that term precision, which is used a lot, we hear a lot that these are very precise techniques or more precise techniques, but precision isn't the same thing as accuracy. A stopped clock is very, very precise, but it's only accurate twice a day, or once if it's digital on 24-hour clock, you know. So I think it's really important to, again, you know, I talked about the terminology being quite loaded. It's important to pick those things apart. And you know, that's one of the reasons that I say that all of this stuff is irresponsible, because all of those points are being very deliberately fudged. And again, coming to this point that new GMOs are new gene editing is GM with better PR, because all of that stuff's being kind of blurred at the edges very, very deliberately. So, you know, we know that new GMOs involve a wide range of techniques for disrupting DNA, and that can and does go wrong. You know, we hear lots of hype around the CRISPR-Cas technique, which is the one that sort of rips into or tears the DNA, and then the developers attempt to control how the cell repairs that damage. Now you will hear that described with different language that gives a very different tone to it, but that is what happens. They're ripping apart, you know, nature's molecules and then trying to control how the cell tries to make good on that. Another thing I think to bear in mind with all of this is that these so-called, or many of the so-called gene edited organisms are actually created with a large number of techniques. So they often include older techniques and newer techniques quite mixed up. So there might be part of the process that uses something like CRISPR-Cas, but they might also use what's known as transgenesis. So that would be bringing in DNA from another species. So lots of this stuff gets kind of layered on top of each other. And it's very, very rarely as simple as it's presented as being in that terribly good PR that's done for these techniques. But, you know, coming back to that fundamental point that's at the top of the slide here, disrupting DNA can and does go wrong. I've listed out there kind of 4 classes of things that go wrong. You get off-target DNA changes. So that's where the DNA molecules in the genome of an organism get, you know, or the changes happen at a different part of the molecule. So they're trying to do it on a, you know, a particular place in a certain gene, and they actually make changes elsewhere. So the targeting goes wrong. But you also get on-target errors. So they're getting to the part of the genome that they intend, but then something that they didn't intend to happen happens. You know, at a molecular level, a different change is made. A third type of thing that can go wrong is where you get unexpected effects of intended changes. So they make the exact molecular change that was intended, but something other than what was planned, other than what was expected, actually happens. And one of the fundamental reasons for that is a lot of genes do more than one thing. They operate in groups together and they influence each other. So, you know, you might think you know what you're doing in changing one gene, but you can actually have you know, other impacts than were intended. And then finally, we've got unintended consequences in the field. So even if you know, you make all the changes you intended, they only at a molecular level, at an organism level, do what was planned. When you get that into the field, nature gets involved and different things happen, because, you know, nature is amazing and clever and will respond. The final point that I've got on there, I've said, you know, wild claims and empty promises, that's about a slightly different kind of irresponsibility. That's the behaviour of those who are promoting new GMOs, which is incredibly irresponsible. You know, there is a very active campaign to remove the regulatory safety net from these very, very new techniques, and that to me is just, you know, astoundingly irresponsible. But also that issue of kind of empty promises, what they're saying it can do. I think what we have to remember here is that 20 years ago, we were told that GM was going to sort out, you know, we were going to get some, you know, drought-friendly crops or drought-resilient crops. We were going to get, you know, we were going to feed the hungry. GM was going to do everything, and it hasn't. Those same claims are being made now, and I think, you know, anyone with a eye on the ball needs to be suspicious about that. So I also said new GMOs are unfair. There is one word for the reason they're unfair: patents. Patents are where corporate control of the food chain starts. And these new GM techniques, whatever you want to call them, the techniques are patented, the products are patented, and already the vast majority of the patents that have been registered have been bought out by the big multinational agri-tech corporations, particularly Corteva, which has come about through the merging of Dow, DuPont and Pioneer. So, you know, big business is on this and it's buying it. Now, the GM-free's position, and certainly my personal position, is that nobody should hold patents on DNA or the food supply. So, you know, this is a fundamental problem with all of these techniques, that can happen. And we also need to remember that it's patents rather than regulation that hands the technology to the agri-tech corporations. One of the things that they do is they make the patents either free or very, very cheap at the experimental phase. So the research institutes working on this aren't worried by the patents because they're not paying much or anything at all. But there's a very sharp rise when you're trying to grow at scale. So that will hugely impact who's controlling the food chain as things go on. And then this is my last slide for this bit. Why am I saying that new GMOs are unsustainable? I think the bottom line here is that GMOs of all kinds support industrial farming. That's partly because GM thinking is linked to the monoculture model. You know, we've got trait-based solutions to systemic problems. Well, you know, you can't fix the food chain one trait at a time. But we've also got to look at what it's being used for. The older GMOs that have been successful are the weed killer friendly crops and the insect killing crops. We hear an awful lot about the hypothetical potential for these new techniques to do different things, but actually the first two gene edited crops that are in the ground grown at commercial scale are Cibus weed killer friendly oilseed rape and Calyx soybean, which is being produced to support repeat frying in the fast food industry. So, you know, it's soya oil from McDonald's. So these techniques have already gone down exactly the same road as, you know, their older cousins. So that's kind of why I say they are fundamentally unsustainable. I've gone very slightly over the planned time, but we knew that might happen. So we've got plenty of spare time built in for questions. I'm going to stop sharing. And see all your lovely faces again, which is very nice. And I'm gonna, unless anybody's got any sort of immediate questions for clarification, I'm gonna hand over to Stephen. Was there anything? Look, everybody looks all right. So over to you, Stephen.
Okay, in theory, you are able to see my slides. Is that cool? Okay, so we know that hello, I'm Stephen Jacobs, Organic Farmers and Growers. OF&G is the largest certifier of organic land in the UK. We were the first to be approved by the government to do so. The slide thing's not working, of course it isn't. There we go. So I can't tell you if that sheep is any relative of Dolly's or not. I'm afraid I've just nicked this from Ellen's website. So moving swiftly on. So I'm coming from an organic farming background. That means that in organic farming, we cycle elements, we cycle energy, we cycle nutrients. That's how we do it. Liz spoke earlier about systemic challenges. The one that we ask farmers to face, excuse me, is to produce food without damaging unnecessarily, and to do that you have to bring nutrients back into the cycle. So that's part of the principles of organic, and the principle of health is that the health of the soil and of the plant, of the animal and of the human are all one and indivisible. So the backbone of organic farming is the plant you can see in front of you, which is clover. So that grows up, the bees come and use it to pollinate and to get the nectar, and the roots will fix nitrogen, all being well, and that will feed the soil. But organic is also under a legal framework. And that legal framework is governed by DEFRA in this country. So we are audited by a DEFRA-approved body every year, and we audit all of our farmers every year. Barring COVID, we are on each farm every year. So last year we did remote inspections, and then this year we're playing a bit of catch up. So these good people are serving and eating organic food. So the organic food market is the other side of organic. So we've got the principles and the practicalities, we've got the legal framework, and we've got the market itself, which, as you can see, is worth nearly £3 billion. So yes, it might be niche compared to some, but it's not that niche. Somebody said worldwide, we are at around $100 billion, which is around the same size as the entertainment industry, oddly. There you go. And the other thing to note is that this figure where it says organic products were bought by nearly 9 in 10 households in 2020. So there's a very high recognition of organic. They might not be buying all of their food organic, maybe it's just the milk or whatever, but there is a very high recognition of what organic means, what it stands for. So to move on to seed breeding, I pinched this off the BBC. I'm sure that won't mind, I paid my license fee. But the idea here is that if you look towards the bottom, it says you repeat the process continuously over many generations until all offspring show the desired characteristics. I chose this because it shows that actually what's happening is that you're not just selecting, your selected breeds, species, whatever they are, will be interacting with their environment. That's what we call evolution. It's where the different elements bang up against each other, and then you can take certain criteria forward, whether they're particularly resilient to disease or whatever. So to take that one step further, you can have what's known as evolutionary plant breeding, and Getcherelli has famously written about this for a long time. You can look him up. There's a lot of really good research on scientific agroecology. So that's not somebody making it up. That's an actual defined version of ecological science that says that you can, with an evolutionary population, so that's a mixture of different plants, produce a species that will satisfy quite a variety of different factors, whether it's for farmer 3, the disease, or farmer 4, the soils, etc. That's because the species and traits that you selected in being allowed to interact with the ecology will stimulate biodiverse resilience whilst also being able to feed us. This slide is from the Organic Research Centre, from the work that the late great Professor Martin Wolf did. These are 20 varieties that were all crossed with each other. The project has become known as the YQ, but it was originally the Wakelin's organic population. So the point of this is that these plants were all picked because they're diverse. These are not heritage varieties. Maris Widgeon, you can see there, is quite an old variety, but it's post-war. But it is quite tall. Yeah. Anyway, what we've got is a situation where when you see it in the field, you can see it on the left here. So just below the tree is the Wakelin's population, the YQ. And on the right, with all those very pretty poppies, that's a mixture of just modern varieties and strips, single varieties. Credit to Mark Lee, who's an organic farmer down the road from me here in Shropshire. This slide dramatically shows what we're talking about. The ones on the right, pretty as they are with all those poppies, are not competing with weeds very well. The poppy is the weed. The ones on the left, which is the YQ population, YQ, by the way, stands for yield and quality, have competed very well with weeds, are tall, strong, looks like a good crop. I spoke to Mark the other day saying I pinched this picture and he said he's never taken a better one. It is a really good pick. So that just shows you what you can do. These pictures are from Ed Dickin. The one on the left, the einkorn. The einkorn is one of those, is pre-heritage. This is one of the first cereals that people managed to grind into bread, flour. You can see the shape of the heads there, and you can see the one on the left is the einkorn and the one on the right is a modern variety, really big, fat grains to that modern one on the right, the one on the left with those lovely awns coming off, quite small. But the picture on the right, you can see that what's going on below ground is that the modern one has less roots, far less. So the older variety is working the soil really well. All of that carbon, which is very popular these days, I'm told, all of that carbon is being put into the soil. When the crop is cut, that stays there. Now, on organic farms, there'll be a certain amount of ploughing. A lot of farmers have reduced ploughing quite a lot, but they'll only be ploughing once or twice in a 6, 7, 8 year rotation. So most of the time, that root matter is in the soil. More pictures from Ed, I think. I can't quite see because this is from Rob Penn in Wales. So Rob wrote a book I would urge people to read called Slow Rise, which is his story of bread. It's a really, really good read. And the one on the left, Yeoman, that's from 1916. So we've come all the way from the einkorn, which is probably 8,000 years old, from the Mediterranean crescent, the Fertile Crescent, those of you that know the history there. And then there's a picture of Rob on the right with his first crop. And then we've got the bread. He's very artistic, not only in his growing, but also in the bread that he bakes. And that's what this is all about. This is not simply for profit, but of course, any bakery, any farmer needs to be economically viable, but they're also producing food that is nutritious and tasty. Going back to the regulations, some years ago, 2014, we asked DEFRA whether they were out with coexistence. Those of you that don't know, that's literally where you have to exist in conjunction. So where an organic or any non-GM crop would have to grow in close proximity, who pays for sorting out any potential contamination? DEFRA said they weren't minded to do anything about that because they didn't foresee it coming on stream soon. So we've asked them again, and they've said pretty much the same thing. So we responded to the recent consultation, and just to cut a long story short, because I can see the clock ticking, these are the points that I pulled out from our other extensive response to the gene regulation consultation. We want robust regulation and risk assessments because that's what we do. We want everybody to do what we've had to do, which is to exist within a strong, robust, and fair regulatory framework. And we will be robust in protecting the relationship that we and those businesses that are licensed with us have built for decades.
And tested for us.
Moving swiftly on, there was a study to look at the costs of coexistence, handily named CoExtra, because it's the coexistence and traceability. The big issue is the most relevant costs are borne at the farm level. So if you're non-GM, you would have to pay. If you're found to have GM, on your farm, then you owe under an intellectual property. And in fact, very quickly tell you, I know a guy, Stephen Briggs, who's a well-known organic farmer and agroforestry specialist near Peterborough. When he was doing his Nuffield scholarship, was in America on one of these huge farms, and he was talking to the farmer. They were getting along. It was really good, looking at trees on farms. And they saw in the distance a pickup truck. Who's that? I don't know. So they went over. Of course, these farms are huge. The guy came out of the pickup truck. They said, "Who are you?" He opened his coat, showed his gun. This is America. Said, "I'm Monsanto. That's who I am." And he was there to inspect the crop. And if he found some of Monsanto's property, then there would be some sort of procedure and legal work to go through. So that's what we're looking at. There's another angle to this, which is beyond trademarking and beyond simply the cost of segregation. I've pulled these out of two studies. Essentially what happened was they saw that oilseed rape that wasn't grown in a country was found on the railway tracks in another country. It was genetically engineered to be herbicide resistant. What's the problem? Well, they use herbicide to kill the plants growing on the railway to keep it from being destabilized. So that's just one issue that has been found. This is not potential, this is historical fact. And of course, there are a lot of examples of when the food system has been found wanting and when supply chain integrity was less than intact. The Horsegate one is a case in point. It wasn't until the DNA was tested, you can't tell, I couldn't tell by looking at a burger that it's from a cow or it's from a horse. And in fact, I was talking to somebody at one of the labs that the government used to run the DNA testing during this scandal. And they said they were asked, is there any dog in any of it? And they said, well, we would have to run the test again. We look for a set of DNA. If you want to find another set, we'll have to do another test. So I'll leave that there. And then let Liz finish up.
Okay, I'll just pause before diving back in case there were any questions for clarification or, but I don't see any hands up or anything, so I will dive in again. This is the last bit of us just talking, so do get your questions organised and ready. So this is, as always, the trickiest bit. I'll just share that and get into presentation mode. It's a bit slow. Hello. There. Are we good?
That's it.
Excellent. Okay. So back to me again, I'm afraid. So what I want to do now is just kind of run through a few words on current regulation, political context. So I think it is useful to have an understanding of the context in which we're operating more broadly. Then some stuff on the immediate threats, so exactly what's happening politically around GM. And then, if Pete wasn't able to join us, I will try and summarise the Scottish dimension. And then I'm going to finish up with some thoughts on how you can all help and get involved. So, current regulation, as I mentioned before, is retained EU law. So that means it's what we sort of inherited from having been part of the EU. It is far from perfect. You know, I'm the last person to say that it's exactly what we want, but it does put, you know, some very important fundamentals in place, and it means that no genetically modified organism can be released without a case-by-case risk assessment, Now, it depends on your perspective whether you consider what happens at the moment independent or not. I've actually put in my notes independent-ish, and that at least somebody other than the developer has to look at it. The regulations require traceability and post-release monitoring, which is what you need to facilitate any kind of recall, and labelling. So any GMO that's in our food has to be labelled so we can choose what we're buying and eating. Now, theoretically, there are also some quite substantial rules on containment and contamination, but as Stephen said just a few minutes ago, the practice around that is not at all well developed in the UK. So, you know, that is a sort of theoretical protection that the regulation offers. So looking at the broader political context, there's lots of things on that slide for you all to enjoy in whatever form you wish. The summary is that we are in the middle of an ideological push to reduce public protections across the board. So GM is not isolated in this. The rectangle, the portrait rectangle on the left, if you can read the text, is says Task Force on Innovation, Growth and Regulatory Reform. Now, that was a group led by Ian Duncan Smith, who produced a report about post-Brexit benefits. And one of the lines in that was that the UK government should actively support research into and commercial adoption by UK farmers and growers of gene-edited crops. Following on from that, we had a consultation on something called reforming the framework for better regulation. So that's where this broader context of this government wanting to have less regulation all round comes in. But then we get on to Boris Johnson himself. Now, on his first day as Prime Minister, having never, as far as I'm aware, having commented on GM ever before, like we were absolutely not expecting this, in front of the door of Number 10 is his opening speech. He said that he planned to liberate the UK's extraordinary bioscience sector from anti-genetic modification rules. Now, I would argue with almost every word of that, but the point that really matters is that this is being presented as a big Brexit win. And also, you need to bear in mind in all this is GM in all forms is legal. So they're not talking about making something legal, making it allowed to happen that wasn't. What we have at the moment is regulatory safeguards, and you know, this liberation means getting rid of the safety net of those regulatory safeguards. Broader context still is that you know, the issue of trade more generally. So trade with the EU, and so the kind of need to match their GM rules to a certain extent. At the opposite end, the pressure to get a US trade deal, and they have much more of an open door to all sorts of GMOs. And then the last kind of broad political context is devolution. So Northern Ireland is operating very differently in lots of ways, but all three of Northern Ireland, Scotland and Wales actually have responsibility for agriculture and for certain aspects of food regulation, or most aspects in fact. And they all have a much more GM skeptic political approach than the Westminster government, covering the UK as a whole. But on these matters, actually the Westminster government only really covers England. So that's all quite complicated as broad political context. Oh, I do apologise. That's me flicking the wheel of my mouse rather than the proper click thing there. So talking about the immediate threats, what's actually happening right now. On the 29th of September, George Eustace, who's the Environment Secretary, announced plans to what he called free up gene editing of plants at the research and development stage. What it looks like he's going to do is change it so that there is no consent needed for gene editing field trials, so gene edited GMOs being tested at field scale. That will mean that there's no independent risk assessment, no monitoring, and no requirement for containment of those field trials. there aren't a lot of details clear, but I'm also very concerned that it may mean that there's no restrictions on the size of the field trials, or any restrictions that there are will be much looser than they are at present. So what counts as a field trial could change. Now, getting even deeper into this, that change will only apply to plants produced by genetic technologies where the resulting genetic changes could have been developed using traditional breeding methods. Now, that phrase, could have been developed using traditional breeding methods, makes no scientific sense whatsoever. And that's not me saying that, it is me saying it, obviously, right now, and it is what I think. But the Roslin Institute, the people who developed Dolly the sheep and who are very active on gene editing in animals in particular, described it as exceptionally challenging. And the Royal Society, who are all for all these changes, described it as problematic. Those phrases, those comments were made as part of DEFRA's consultation this year. It opened in January and ended in March. The results of that were announced, I think, 9 hours after the embargo lifted on George Eustice's announcement. So it's a very odd timing, which we can maybe talk about later if people are interested. But that consultation showed that 88% of individuals and 64% of businesses were opposed to plans to remove GM safeguards from new gene editing GM techniques. Now, this change that's been announced will come via what's called a statutory instrument, which is secondary legislation. That means there will be very limited scrutiny. It will be almost impossible to stop it. In itself, it's relatively small, but it sets a precedent. It sets a precedent of this bizarre framing of something saying, well, we're going to change the rules because the thing you did maybe could have been done in another way. So that means the regulations don't count. I mean, that's no way to write the law, but once it's in, it'll be very difficult to stop it being applied to other issues. They're also testing what they can get away with. It's incredibly important that we have a big response to this, even though we probably can't stop the statutory instrument. They need to know that the population is not going to take this lying down, that the farming community is not going to take this lying down. And to make things even more confusing, all of those changes to the field trials will only apply in England because of the devolution point that I raised earlier. And that takes me on to the Scottish dimension. Yes, the changes will only apply directly in England, but that doesn't mean that our Scottish and Welsh colleagues are home and dry. Very much not, in fact. The changes that George Eustice announced, only apply to trials in England because of that devolution. We've got a picture of the border. The border runs through the middle of a field in lots and lots of places. So seed and pollen don't respect national borders. If it's there's no way that you can actually contain something over a national border, and so it's going to be incredibly difficult to hold the line physically at a kind of organism farm level. But also politically, it's going to be extremely hard to hold the line. Much of the UK food chain operates on a UK basis anyway, but the Internal Markets Act is going to prevent Scotland and also Wales from putting up any barriers to the sale of English products. So if it's allowed in England, you can't stop it in Scotland. So they're very kind of curtailed on that. But also the other thing we need to bear in mind is that the Scottish government's commitment to a more GM sceptical point of view is a little bit untested, and it's very tied up with what's going on in the European Union. I mean, I think as far as I can understand it, that the basic political position in Scotland is we're going, we want to leave the UK and go back into Europe. So they want to retain alignment with Europe. And the tight regulatory status of these techniques in Europe is not secure. So basically, there's a whole lot of mess there that, if people want to explore further, we can get into the questions. Where I'm sort of taking up a lot of time. So I'm just going to quickly summarise some stuff that you can do to get involved. The real food and farming movement is creating and promoting the alternative food system that we all need. But we really, really need the movement to also get involved in the other side of that equation, in fighting the GMO threat, because it is coming. And the people who, you know, are able to dedicate themselves entirely to this are tiny. There's like, you know, my organisation is me and one part-time administrator, and there are maybe 2 other organisations of similarly tiny size working on this. We can't do it on our own. So the 3 things that I kind of want everybody to do is, 1, don't believe the hype and be very careful about the language that you use to avoid repeating it. If you want just one thing to remember, is that gene editing is GM, it's just GM with better PR. I want you to sign up for my emails. I'll share that link in the chat. I might have already done so, I can't remember, sorry. But also, you know, share this in your networks. For all that it's a tiny organisation, all this online stuff means that I can come and speak at your events, I can come and talk to organisations, and I can share resources. So please, please use the specialists that are here and help us spread the word more widely, because this is coming and it is going to make it much more difficult to hold the line on the real food and farming movement. So thank you.
Thanks, Liz. We'll move over to some discussion now. So if anybody's got any questions, it would be great for you to raise a hand, or you can submit them via the chat. We've had a little bit of back and forth in the chat so far. We've just got one question coming in around the question of throwing the baby out with the bathwater in terms of GMO and gene editing. And I just wondered if you had any reflections on the kind of...
What does that mean?
From this, Alan Blessing, would you like to come off and speak your question on the microphone, or I can repeat it? Okay. So I think the question is about the kind of purported benefits of gene editing. Yeah, okay, that's fine, Blessing. And if you think that there are some benefits there, and if there aren't, what do you think are the other ways that we can provide solutions to the problems that we're facing in terms of climate change and so on?
Absolutely. And I completely understand why people ask that question. But before you ask a question of the food system, you have to appreciate that the food system is complex. So any solutions to challenges in the food system need to be complex. There was a paper a couple of years ago published on the Lancet, and it was called the Global Syndemic. And the syndemic is a multiple of endemic conditions. There was obesity, malnourishment, and biodiversity loss. And you could throw in climate change with that. That each exacerbates the other. So for instance, we need more productivity. Do we? There's just less, I think, around 1 billion people today are going hungry all over the world. There are around just over 2 billion people who are overweight. The UN estimates that if food waste was a country, it would be the 3rd highest emitter of greenhouse gas on the planet. So no, I don't think more productivity is what we need. We need fairer distribution. We need better recognition of dietary requirements. We need a more stable or more robust way of producing food in what is becoming an unstable climate.
Stephen, did you want to come in, Liz?
Yeah, absolutely. And I think the other thing, I mean, Stephen's absolutely got it, you know, on the money, in that we're looking in the wrong place, that traits are not the answer. But even if a trait is an answer to a very, very specific problem, and even if one of these new techniques is the best way of doing that, I mean, you know, if you can set aside the patenting, maybe you can have it not patented, maybe. Regulation does not stop that. What regulation will do, if you get the regulation right, is ensure that we only do this if it absolutely is the right thing. If it's not, you know, got all these side effects, if it's not, you know, going to cause, you know, immediate health risks. It's what we have to remember here is that the government and those promoting GM deregulation are very much framing this as, you know, they're stopping us having the wonderful thing, and we want the wonderful thing, so we can't have the regulation. But what the regulation is doing is checking that we only have it if it really is wonderful. So if it, I often wonder this, if they think that what they've developed is so brilliant, why are they afraid of somebody looking at it? Why are they afraid of getting their homework checked? Do you know, and I think that's because corners are being cut. Like, why would you not want somebody to independently check that your brilliant thing is brilliant? You know, think how much more you could charge for it if it was independently verified as brilliant. So I think you have to kind of look at and this is why I talk about the PR quite a lot, because there has been so much investment in rebranding and kind of representing this. Though the GM developers, GM companies learned a lot from the early days of the GM movement, whereas unfortunately, most of the people who were involved in the anti-GM movement in the early days have just moved on and dealt, you know, and campaigned on something else, and have probably done a brilliant job in getting climate change up the agenda. So it's not like that was a bad thing, but it's a bad thing for GM, because all this time they've been working on their narrative and we have not. So we're really behind the curve on that.
You raise a number of interesting points there, Liz. One that builds in on that is a comment from Bill Grayson, talking about his concerns around gene editing being presented as a solution, but it's really committing us to more of the same in terms of what our food system needs or doesn't need, and pushing the same corporate agenda that's got us into the same mess. So, and I just would also ask you to reflect a bit on this, why there might be a push for deregulation. And you mentioned about maybe testing the water for future deregulation of other things, and I just wondered if you could reflect a bit on that, both of you. But Liz first, please.
Yeah, sure. I mean, to sort of go slightly backwards up that chain, I think there's several things being tested here, and the context for that is that we have a government, and to some extent even an opposition, who see enterprise and innovation as fundamentally good things. So innovation is being presented as a public good in itself, and I think that's a real cultural thing that's been going on for a very long time. I don't know if anybody remembers the I think it was the early days of David Cameron. There was a lot of talk of the information economy, and patenting of genetic modifications fits very much into that idea that what the UK is good at is sort of clever science, and so how do we monetize that? We patent it and then we make it freely available in the food chain. So this starts, I think, very much from an economic model and at a particular way of seeing the world and seeing corporate control as a good thing. So, you know, there's very much a perspective there. So that's that broad deregulation agenda. I think in terms of deregulating, removing the safety net of regulation from gene edited GMOs in the UK, they're testing, so the UK are testing what they can do. They're testing on a little thing, the trials, to see how much people will stomach and whether they can give very free rein across the board. But also, I think there's an element in which the UK is a bit of a test bed here for Europe. So the European Union is very much dealing with the same debate, and you know, they're never going to say that they're being led by the UK, and they probably aren't in lots of ways, but every domino that falls will, you know, change the broader picture. So I think there's lots of ways in which this matters more than just what will specifically happen first. And now I've done the thing that I was afraid I would do, with starting at the end of the question. I've forgotten the bits that were before. Can you remind me, Charlotte, what else we were looking to cover?
That's great, because you fed in on what Bill was raising and is coming up in the chat as well about the fact that we're kind of heading down a path which is also one that we've already trodden.
Yes.
So,
yes, and well, yeah, that was the other one of this. Is this, like, you know, I used the word innovation there, and I paused a bit. I don't like applying innovation to this because, like, yeah, the actual method for ripping the DNA apart, that is quite new and that is terribly clever. But the concept, the approach, the attitude, the model is so old hat. It doesn't even reflect, you know, modern understanding of genetics. It presents DNA as if it were Lego that you can kind of pull apart. And I always think about, I've got teenagers, and like once in every high school child's life, they get the homework where they have to make a model of DNA with things around the house. It's my favorite thing in high school because I studied biochemistry and I love it. And it reminds me of that. And, you know, you can make a workable model of DNA out of bits of pasta, and, you know, we use, you know, those little packing worms and stuff like that, and it's great fun, and you color it all in with felt tips. Like, that doesn't mean that's what DNA is like. Like, it's just a model. It's nothing like that. It's not remotely like that. It's not like the pictures that they show us. It's not like, here's a gene, here's a gene, here's a gene. Oh, just take that one out and it'll all be fine. You know, it doesn't work like that. DNA and genetics is phenomenally complicated. Do you know, and I studied my biochemistry quite some time ago, and almost everything I studied on genetics has now been superseded. But I'm still younger than a lot of the people who are leading the scientific kind of decision making on this. And to people bring that old thinking along with them. You know, DNA is not read in a line. You're given very, very simple models all the time. So I think there's complexity at the molecular level. And then as Stephen was saying, there's so much complexity in the system. And then yet again, we've got the complexity of nature and nature's response to these things. So actually, it's not innovative, it's just patentable. It's just business. It's actually a really, really old-fashioned approach.
Yeah, well, I think we're all well aware of people that are at this conference and members of the audience that, you know, systems are complex, and that's one of the challenges we come across working in agroecology and our alternative food and farming approaches that we're trying to adopt. And I mean, that's another reason why regulation is important, to kind of buffer against that. And I just wondered, Stephen, having worked in the organic industry, you know, regulations are part of that, and the challenges of regulating and how you kind of evolve over time as knowledge and understanding changes, and how that process works, and how you think that's important in the context of GM and GE.
Yeah, well, one of the things is that when we work quite closely with our organic licensees, you can hear me all right, can't you? Because I'm on the tablet now. The computer decided to have a little rest in the middle of the Zoom. And I was with, for instance, Mark Lee, who took the picture I showed earlier, and we were. I was filming a crop assessment last summer, and I said to him, "You got the crop in okay the year before, because the autumn of 2019 was very wet." And he said, "Yeah, partly because he's doing strips of stuff. So because he's selling wheat milled to himself now, but also to other people to mill themselves in a much shorter supply chain, gives him better control, gives him a better margin, etc. Also makes him a little lighter on his feet, being able to get the crop in the ground. But also, he found that in all of that rain, and there was a lot of it, that he wasn't affected as badly as his immediate neighbours. And he reckoned that that was after 20 years of putting composted plant waste in as part of its organic rotation. He's got that much fibre, that much life in his soil, that he was able to withstand what other people were finding was a flood. For him was quite workable. So that's a huge, huge difference. And that's one that Mark has discovered on a 20-year journey. So it's something that we then make sure other people can share. I copied that video. I'm not sure how to do it on the chat while I'm on the tablet, but if people ask, write to me via OFG Organic. It's Mark saying it in his own words. And just going back to one of the things that was talked about with like that complexity, gene editing isn't just about plants. I did put in the chat in answer to, I think it was Martin mentioned some interesting fiction talking about this sort of genetic science. There's a very strong likelihood that there will be human engineered products going through at some point. There was a bit of a hoo-ha, was it last year or the year before, with a Chinese laboratory saying that they had manipulated the DNA in an embryo using CRISPR. There was a call for a moratorium, very difficult to do, but what you what you can do, what makes everybody more comfortable and safer is to have strong regulatory frameworks and a good auditing system through the supply chain, whatever you do. I was at a round table organised by the then DEFRA Secretary of State, don't know if any of you have heard of him, Michael Gove, a few years ago, and he called together us, and so there was Beyond GM with there, I was there, but also so was Ottilie Laser, who is now the head of the UKRI, the United Kingdom Research and Innovation Fund. And Ottilie talked about how the ideas that they were working on were for export. But what they wanted to do was to feed the world by selling this technology at a very high price all over the world. And it's that kind of angle that people who support that idea think it's perfectly, that's a responsible approach. It's just business, let's do it like that. But what we've already highlighted, and I put a link in the chat, the global syndemic paper, is that more productivity is business as usual. It doesn't address the crises that we're in, and it cannot. And until we, I don't know, have a cold shower or something, wake up and smell the coffee, as the Americans would say, we're not going to solve the problems that we are already finding are causing damage that is almost irreparable. So at some point, we have to understand how food systems work. And to do that, it's not complicated, it's complex. You have to take each stage, work out where it hits everything else. And that's where I think this idea of just cutting DNA falls over.
We had a comment from Alison Morgan, about how we do have options that we can learn from the past. And you presented some of that as well in your presentation, Stephen, alternative approaches, using heritage varieties, for example, but also innovating, if that's the word we want to use, in agroecology itself, and how Alison commented about golden rice being hailed as a miracle, which never delivered, and the fact that they'd been supported by 17 different crops previously, including green vegetables, and then it all kind of got disrupted by the arrival of golden rice. I mean, do you want to come off, Alison, and say a few words on your reflections on what we've heard today? You're very welcome to.
I think it was just an observation that to have variety of, I mean, I'm thinking particularly of vegetables actually, and seed banks, and looking at how people did things in the past. It's that keeping away that monoculture, isn't it? Keeping the variety of species of grains or vegetables that people have always had, and not being bullied by the big companies that are just giving you a smaller choice. And I think as a small grower myself, that's what I feel is, one of the big challenges really.
Yeah.
And yeah, just this feeling that science will cure everything, when actually, you know, that I'm not against science. I'm not against, you know, looking at the way that plants grow and stuff. I don't want to be sort of medieval and saying no, it was better before. But it just seems to show, when you read and look at examples, that to have biodiversity and choice of things that you grow is better than trying to get the perfect thing that everybody grows. That was my point, really.
Yeah, I was just following on from that, is there's a very good science out there with a thing called MAGIC, MAGIC. I can't remember what it stands for, but it's been around for ages. It's to do with you sequence the genotype in order to work out what the phenotype, the traits, are going to do. And actually, Nick Franklin in NIAB is working on a doctorate around that. I think he's nearly finished. And he started to find, and this is, you don't interfere with the DNA of the plant, you're simply sequencing it.
Right.
And what he does is he looks at all these different varieties and works out whether they're going to be good at competing with wheat, like I showed in that YQ population, which was not through the MAGIC process, but the MAGIC process is a way of selecting and predicting. And he's worked out how to predict quite a lot already, and he hasn't cut any DNA other than to put it under a microscope. And I said to him, but they say that CRISPR will speed up breeding. He said, Stephen, I could breed 1,000 times a year in the greenhouse. No CRISPR needed. So actually, he said, I don't really see the need for it in plants. He said maybe in other things there might be a need for it, but he wasn't clear where that need would be. So yeah, I think it's somebody had a go at me on Twitter, which is a common sport. And we responded to the government consultation and said, but your COVID jab may have been one of the mRNA ones. And I said, yeah, but that's within a regulated framework. I've had my jab, I support it. Next question. They went silent at that point. So I think there is a need to not be too emotional, not to throw out the science either. It's just a case of what is appropriate and where. And also, as Liz said ages ago, there's a lot of money behind this. And I think that's what it's about.
Wakelands is a very good example, isn't it? The YQ, yeah.
What happened there was that actually I found an old paper, Charlotte, I'll send it over to you. I found it the other day, it was just sitting on the internet, which you've probably seen anyway, which was when Martin first proposed, or it was an early ORC report on Martin going through some of this stuff, because the John Innes Centre helped him select those first few. Really interesting. He was just looking for biodiversity in order to have a strong, healthy field, a robust food system, as modern parlance would have.
Because I've been part of a local bakery as well, and so that interest in grains and knowing about Wakelands, that was something that really kind of got us fired up, really, and trying to use locally grown wheat up in Yorkshire. It can be done. It can be done.
Yeah, well done.
Have you got a loaf you can show us, Alison?
Half eaten.
Oh, okay. If I can just sort of come in here with a slightly different perspective, I think very much along the same lines with all this. I think one of the things that happens is that different individuals, different institutions, different bodies approach a problem from a very different angle. And you know, that I've had quite a lot of interactions with Ottilie Moser, who Stephen mentioned earlier, and actually she strikes me as an incredibly well-motivated person, very smart, you know, has done phenomenally well for a woman in science. Where she and I absolutely kind of split paths and go in different directions is that she asks, how, you know, she sees something wrong in the world and she thinks, how can I apply the thing that I'm good at to fixing that problem? Whereas what you have to ask, I mean, maybe I ask this because I don't have a thing I'm so utterly scientifically brilliant at as she does. But, you know, to me, what you have to ask is what caused that problem? And what can we do to address the root cause of that problem? And that's where it all becomes political. You know, the golden rice example, you know, got brought up. And, you know, if you sit and you think, well, oh, people are only eating rice, you know, they're living almost entirely on rice and they're not getting any vitamin A, that's terrible, let's add some vitamin A. Well, that sort of sounds like a nice thing. But actually, what you should be asking is, why on earth are they living on rice? What has caused that? How can we fix that? And there's a risk with this that you just eventually sort of come back to, you know, colonialism and patriarchy and capitalism are the root of all evil, which so you have to be a little bit careful that you don't, you know, that you find a scale at which we can act. But we can absolutely act on waste reduction, on, you know, the unfairness of financial distribution around the world, you know, on actually addressing what's wrong, because rice isn't supposed to have vitamin A in it, because you're not supposed to just live on rice. You know, there's lots of other things it doesn't have in it, because you're supposed to eat other food as well. So, you know, I think a lot of the time it's about asking a bigger, broader or deeper question.
And that whole vitamin A thing, there was a piece of work that came out a little while ago that talked about how the vitamin A, the beta-carotene in milk, is in the fat. So having skimmed milk, particularly, or even semi-skimmed milk, is to take some of the essential trace elements out of that product. Now, we've known that fat, for some time, we've known that fat is not the demon. It's the processing involved in the food. And yet we still do it. So at what point will a gene-edited, unregulated foodstuff come up against something like that, a road bump, where people are getting ill or they're not being made well by the food they eat? Who's going to pick up on that? That's where I start getting really, really quite nervous.
Me too.
Thinking about addressing problems, and you know, we have systemic problems and we have specific problems, but Liz, I just wondered whether you could reflect a bit on the recent trial that was submitted to
the burnt toast.
Yeah,
the burnt toast week. So I mean, this is interesting, I think, also because it's these field trials that are the first target for the government's deregulation push. So what happens if a research institute thinks they've got something that might work, that is a GMO, they have to apply for consent to grow an open field trial. So they can grow it in they can do whatever they like in labs, they can grow stuff in greenhouses, but once they want to put it into a field to test how it copes with the weather and all the rest of it, and soil, they have to apply for consent. And part of that process is a public consultation, and that's something that GM Freeze gets very involved with. So this year there was an application for a wheat that was very much portrayed as a gene-edited wheat, and it's the first of its kind and all the rest of it. Actually, it was the researchers who originally, Washington Research, it was them who originally referred to it as being about burnt toast. And they had a picture of burnt toast on their website. They don't anymore. They've stopped talking about burnt toast. I have to say, I like to take credit for that, because we teased them mercilessly on social media with a picture of a guy panicking in front of a toaster. And, you know, there was a lot wrong with that trial. It got consent, because they always do, but we raised a number of concerns, and by doing that, it is in the system that those concerns are registered. And there were huge concerns at the molecular level. They were using this CRISPR-Cas tool that rips the DNA apart, and actually it was still in there. So the mechanism that does that should be removed before any of these organisms are, you know, released into the environment. It actually was still operating. So this stuff isn't like their experiments aren't finished. They're trying to put it in the ground very, very quickly. And the change that they had intended was to reduce the levels of something called free asparagine. So that's an amino acid, one of the building blocks of protein, that is in the plant in lots of ways, but there's also some that floats relatively free. And that, when cooked at very high temperatures, can produce acrylamide, which is thought to possibly be a carcinogen, so something that causes cancer. And there are some targets to reducing that in processed food. However, Cancer Research UK say that it's not a problem, that you don't need to avoid it. So there's a whole issue there about, you know, whether it's an issue at all. What I think my absolute, well, essentially, you know, I think sort of a second level concern about this was that it's burnt toast, it's burnt bread, very dark coloured stuff, that wheat that contains acrylamide, and it's actually potatoes that are the really big problem. It's crisps, burnt crisps are where it's a real issue. We probably shouldn't be eating as many crisps as we do anyway. But you know, to buy a toaster that works, don't burn your toast is a rather easier approach than genetically modifying the bread. But also this wheat, they discovered that it didn't germinate very well. And you know, hey presto, when you interfere with one thing, something else doesn't work. So they didn't set out to stop it germinating well, but can anyone guess? This is just hilarious. What they did to improve the germination level, so that the genetic modification had reduced the levels of free asparagine. What do you think they physically put on as a topical application to the seedlings to make them germinate well? Anyone
Burnt
guess?
toast.
Well, almost, yeah. Acrylamide. they put asparagine on. So they made a genetic modification to take it out, and they were like, oh, it doesn't germinate very well. Oh, maybe if we put some asparagine on, it might. And they didn't make any flour out of that to see whether that would produce acrylamide. So it's absolutely mind-boggling. And this stuff is in the ground. And actually their PR has already changed. The last time there was a press story about this, it wasn't about toast. It was actually about breakfast cereals and how it's going to save breakfast cereal. I presume it's like, they mean like Weetabix or Shreddies, that people, apparently people like them to be dark toasted. I think what people like is them to have loads of sugar in them. That's certainly what children like. But the news story is that this stuff is going to save breakfast cereals, which are being, you know, so like, I think what that demonstrates is there's huge technical problems with this, but also B, this is an application looking for something to solve. It's a solution looking for a problem. They're desperately trying to find something they can do with this stuff. And you know, that just blows my mind. It's like, are there not enough real problems in the world to put your time and your brain power onto? But apparently not.
Well, I think a lot of the problems that we're looking to solve are not going to be so straightforward. Even in breeding, I mean, it's going to be complex traits which determine pest resistance, responses to extreme weather events. It's not going to be single genes that control that sort of thing, and the genome is still very complex and we still don't understand a lot of how it functions. And then we have other factors. So we had a question about epigenetics, and yeah, that is a big part, you know, in how we see the final traits that we observe in the field. And just because we even know the sequence of a genome doesn't mean that it will necessarily translate to a certain trait once you get it in an environmental condition. So yeah, did you want to reflect a little bit on that, Liz or Stephen?
Well, I was going to say about the heterogeneous material stuff that you and I have been working on, and other people. So there is a problem in this country with seed breeding. And during the Conservative government under Margaret Thatcher, I think it was 1987, a lot of the public seed breeding stations, the last one to go was Cambridge, was sold off by the government. I mean, funnily enough, it's not at all funny, it's horrendous. The government were instructed by the Charities Commission to give some of the money back because they were a charity and couldn't be sold. But anyway, they even couldn't get that right. But it meant that the seed breeding has largely been in the hands of private enterprise. And the only the strongest regulation around that is to do with plant breeding rights. And if you register your new variety, it has to conform to two things. One is DUS, which is distinct, uniform, and stable. The other is VCU, which is value for cultivation and use. So that there's a point to it. What are you doing it for? The distinct, uniform, and stable thing is what Wakelin's YQ is not. But over time, it's more stable than, for instance, the other one I showed you where all the poppies were. That's not going to keep going for very long, unless you pour loads of chemicals on it, which, as we know, is perhaps not a good thing to do. So it's what do we do about this? And Alison, there is a Yorkshire Grain Alliance up the people. There is now, we're building a map. There's quite a few. There's an East Anglian, there's an East Midlands, there's I chair the Welsh Grain Forum, there's a Common Grains in Scotland, there's a Southwest Grain Alliance. So we are trying to put our heads together to work out how we can build good seed and how we can get government to recognize that that is worthy of support, if possible, but certainly not being harmed.
And actually, if I can come back on that epigenetics thing, I think there's, I will use a very imperfect analogy, just because analogies always are imperfect. But I think just before saying that, so I studied biochemistry in the very late 80s. I was very young, obviously, and the word epigenetics was not used. That was not a thing. So that's how new this stuff is. That's, I talked about all the things that we're learning, in our lifetimes, how quickly the science is changing. But epigenetics is basically kind of the science of which genes are working when, what other factors influence how genes are expressed, other than just the DNA that's there in that lovely double helix that we can make at home with our pasta and felt tips. So it's kind of what are the factors that make genes express in certain ways. And my really imperfect analogy, so please do share better ones if you've got ones, but I kind of think it's a bit like, the DNA is a poem, and it's a set of words that you may or may not be able to read. You have to understand the language that it's in order to read it. So most of us can't, because it's in sort of super science language. But the environment in which that information is functioning is like the melody that turns it into a song. So the actual expression of it is influenced by all the other stuff going around it. So the music, the melody, the orchestra that is making it into an amazing song that we're all going to buy and make the Christmas #1 is where the epigenetics come in. So the same words can produce something very, very different with different melodies, different orchestrations, and the same is true of epigenetics, that lots and lots of factors in the environment, in the organism itself, will impact how genes are expressed. So that's completely outside the scope of all this kind of Lego model of changing DNA in order to make the things we want to happen. That's completely ignoring that whole function. And again, this is where I've always come back to regulation isn't about stopping things happen. It's about ensuring that they only happen, they're only done if they're going to do something good, if something bad's not going to happen as a result of them. It's about protecting society. Regulation is society's tool for keeping us safe, for keeping animals when we talk about farmed animals, safe, and for keeping the environment safe and secure. So regulation is how we keep an eye on that stuff.
Yeah, so the environment is extremely complex, and genome functioning is complex as well, and the interaction between the two also adds complexity. So it's hard to build systems and regulation that can work within that, and that's something that has come out with the seed registering processes, which Stephen mentioned. So we've ended up with systems that can restrict it and restrict diversity and control these complex processes. So we have lots of ideas of alternative approaches, but they also tend to be more complicated stories. And I just wanted to close whether you would both like to reflect really on how do we develop a narrative which can counter this very simple story that they've developed around GM, that doesn't kind of just leave people feeling thoroughly overwhelmed by the complexity of what's needed and what we can do. So if you want to go first, Stephen, and then Liz close. And then
well, I'll tell you a story. I started OFG in 2007 and very quickly worked out that one of the areas where we're lacking in organics in Britain is in cereals, in grains and pulses. And why? Partly because we're so specialized in this country that it's mainly on the right-hand side. On the east is a whole lot of cereal farms, and on the west, on the left-hand side, is a lot of livestock, and there's, it is quite split. And so we've got people who are growing here and there, but it was a case of bringing them together. So we built this show, which is called NOC, which is a National Organic Combinable Crops, every July on an organic farm. And that was going quite well. But then I was introduced by Josiah at Hodney Dodds to Kim. So Kimberly Bell runs a bakery in Nottingham called the Small Food Bakery. And Josiah and I were talking, this was years ago. I was frustrated with Martin's YQ that we weren't able to show the growers a commercial reason why they bother growing. There was a good reason why they grow it, because it grew well, but who are they going to sell the grain to? All the big bakeries were going, it's a bit heavy for us. Anyway, Kim, according to Josiah, was working on a loaf. And this is the point of the story. Now, you bring people together over the breaking of bread. I wrote a blog for the Wales Real Food and Farming Conference and ended it with the same thing, where company comes from the French compagne, which is breaking of bread together. That's where it comes from. So we got Kim, came to our event. She, bless her, had like one of those sort of painter table things and put some brilliant organic sourdough YQ bread that she baked and some cultured butter, which was gorgeous, but it was July, it was all melting, and was handing out buttered bread to the farmers and saying, this is the YQ. And the farmers were going, now I get it. So I think it's around the smell, taste, and sight of really good food and people enjoying it together. I know that sounds a bit folksy, but I really think so.
No, I think you're absolutely right.
Yeah, I mean, who can argue with good bread? It's just so fundamental, isn't it? Apologies to anyone on the call who's gluten-free, not by choice, because we're probably really, really rubbing it in at the moment.
Manchester, there's a lovely bread company that was started by one of our bakers, and it's called Compagno, which exactly that story.
We do I'm in Manchester, we do occasionally buy their bread. I have to say, my husband makes most of our bread.
That's okay. No, for the Real Bread campaign, buy proper bread or make your own.
Yeah. And also, if anyone wants to ask me offline how I turned my husband from quite a bad bread maker into a really good one, I'll let you in on the secret. Involved a Christmas gift. He makes fantastic bread from scratch every week. But to sort of, I want to bring in another thing here, and I've shared a link in the chat to a part of the GMP's website, where there isn't that much content at the moment, but there's a link to a session that I was involved with at the NRFC Global Conference back, gosh, at the beginning of the year. So GMPs has been doing a lot of work around something which in sort of communication circles gets referred to as framing, which is this kind of, it's looking at the language that we use and why the choice of very specific language has a huge influence on what we're saying. So I think, you know, Charlotte was asking, how do we change the story? And yes, you know, we break bread and we show what real good food looks, smells and tastes like, but we need to be careful about what we say, and we need to practice saying things that actually communicate what we mean. So, you know, I've used that phrase a lot, gene editing is GM with better PR. We need to say that. We need to say that a lot, and we need to own it. And one of the things I'm working on at the moment is some new images. I don't know if you've seen this. Whenever people talk about these gene edited GM techniques, they tend to share images of a pair of scissors cutting into a model of a double helix. They're not scissors. They smell like a hand grenade. Do you know, this stuff is not, so I'm not talking about cutting anymore. I'm talking about tearing, ripping the DNA, because that is what happens. This is not that clean process that we're being led to believe. And you know, the language has hugely run away with us. We weren't on top of this, and we need to get much better at it. So it's something I'm doing a lot of work on. I'm going to be sort of sharing resources on over time. So, you know, kind of get in touch, talk to me about it. But, you know, please, if there's one thing, don't perpetuate the idea that gene editing is a completely different thing. It's that there's GM on one side and gene editing somewhere else. It is not. It is very much part of the same process. It's a form. It's just the latest version of GM. And please, you know, make that plain in what you're saying. And if you go to that link, you can watch the webinar from before. We worked with a fabulous guy called Ralph Underhill, who explains all this stuff much better than me.
Thank you, Liz, and thank you, Stephen. We're going to bring things to a close now. Thanks everyone for your comments and questions on the chat. It's been an interesting discussion, and I haven't managed to read out everything that's been covered, but we'll save a copy and we'll reflect on everything that's been discussed. And it's great to see some solidarity and looking for an alternative narrative. So thanks again for joining. Ellen's got some noisy, I guess, children in the background, so I'm gonna, oh no, not children.
Oh, something else.
Some background noise, so she's going to say thank you as well without coming off mute. And yeah, we'll close there. Thanks everybody.
Yeah,
Thank
thank
you
you very
all.
much.
Thanks all.